Okay, I think we are ready to talk about subtracting integers. Now, you might look at the example in front and say, wait, subtracting integers, why is there an adding sign? Because I want to show you something, and I want to show you how subtracting is really the same thing as adding. Who knew? So remember we talked about the algorithms. What algorithm do you see right now? 5 plus -2. Algorithm 3. Why? Because you have a positive and you have a negative. All right, so with algorithm 3, you subtract their absolute values. So the absolute value of -2 is 2. So 5 minus 2 is 3. Now, is that 3 positive or is that 3 negative? Positive. Why? Because we had more positives to begin with. 5 was the higher absolute value. So the answer to 5 plus -2 is 3. Now, how can we write this problem still using the same digits, 5 and 2, and getting the same digit answer, 3, but maybe changing the signs a little bit? Well, think about it. 5 minus 2. We learned that in kindergarten. 5 minus 2, 1, 2, 3 is 3 as well. These two problems mathematically are the same thing. This is like saying you have a positive 5, adding a -2 is like taking a positive 5 and just subtracting 2. Mathematically, same thing. Now, you can think about how to subtract integers by still using your 3 adding algorithms by looking at the signs. So what I want you to understand is in math, technically a minus sign, a subtraction sign, can be interchanged for a negative sign. Vice versa, a negative sign we can interchange as a subtraction sign. So looking at this problem, 3 minus 8. Okay, so first of all, let's think about it conceptually here. If I have positive 3, $3, I subtract 8, which means I'm spending $8. I can't spend more than I have. And if I do, I'm going to be in the negatives. So it's going to make sense that my answer is going to be negative here. Okay, so let's think about it now using our algorithms. Look always at the sign in front of the number that you see, the digit that you see. So what sign is in front of the 3? No sign. That means it's positive. Okay, what sign is in front of the 8? A subtraction sign. So we're going to think in our heads that that's like a -8. So if I have a positive 3 and a -8, what algorithm is that? One positive, one negative. Algorithm 3. Algorithm 3 is subtract the absolute values. So 8 and 3, if we subtract them, is 5. Now, this is where a lot of people mess up because they think 5 is our answer. But remember, if we thought about it, we started with positives and we subtracted 8. If you subtract more than you have, you end up with a negative. So it's a -5. Now, how would I have known that using my algorithms? Well, if I had a positive 3 and a -8, because I'm pretending that subtraction sign is like a negative, I had more negatives in this problem. So that is the reason that my 5 is a -5 for our answer. Now look at this green example. This one's a hard one because of that subtraction sign and that negative together. Now, negative also means like opposite because negatives are opposite of positives. So here I have a -2, and then I'm going to subtract the opposite. So what is the opposite of subtracting? Adding. So I don't have time to go into conceptually how to quite understand -2 minus -3. So hopefully you've done that in class. But I want you to understand that these two problems are exactly the same. So anytime I see a subtraction and a negative together, I immediately do this. And I rewrite it so that there's not a double sign in the middle. So -2 plus 3. What algorithm is that? Algorithm 3. One's negative, one's a positive. So I subtract their absolute values till I get 1. Now, is that one positive or is that one negative? Don't look at the original problem. Look at the one that we changed to that plus sign. I have more positives, which means that 1 is a positive. In the next video, we are going to practice doing more problems and more examples with subtraction.